Hello, welcome to the video. In this lesson, we're going to be looking at section 10.4, where we're going to be looking at inscribed angles and polygons. So the first portion of this, we're going to answer the question of how are inscribed angles related with respect to their intercepted arcs. And also, we're going to look at angles of an inscribed quadrilateral and how it is related to each other. So first, we're going to take a look at inscribed angles and intercepted arcs. So an inscribed angle is an angle whose vertex is on the circle and whose sides contain chords of the circle. So in this particular one, you can see that line segment AB is a chord, and you can see that line segment BC is a chord. So they both of those chords make up the angle ABC. Now, looking at this, it says here that angle B intercepts line segment AC, which creates that arc. So angle B is part of the relationships for arc AC. All right. Now, with that, it says that if when they're looking at intercept arcs, if the endpoints of a chord or arc lie on the sides of an inscribed angle, then the chords or arcs is said to be subtext of the angle, which means that they have sort of a relationship between the inscribed angle and the intercepted arc, which there is a theorem for that. So looking at this with respect to the theorem, and if you so have, excuse me, if you so have an inscribed angle, so in this case here, the measurement of ADB is going to be equal to half the measurement of this arc. So what you can say is, for instance, if this here was 80 degrees, that means that um, the arc measure for AB is going to be 160, because this angle here, the inscribed angle, is half the size of the arc measure. So with that being said, we have some examples here. So the first thing they want us to do is they want us to find the measurement of angle T. So angle T is right here. So angle T is right here. And what's going to help us is, oh, we know that this arc measure RS is 48 degrees. So knowing that this is half the distance, that means that the measurement of angle T is 48 divided by 2, which is 24 degrees. The second example here for part B is they want you to know the arc measure for QR. So QR is right here. Now, looking at it initially, there's really nothing here that tells us anything, because there's no like, oh, there's no angle measure, that says, oh, this is exactly what it is. But what I do know is arc TQR is a semicircle. So that means that TQR, that arc is 180 degrees. We also can say, well, that arc TQ is going to be 100 degrees, because since this is 50, you take 50 times 2, you get 100. Now, knowing that this semicircle is 180, so I'm just going to take 180 subtracted by 100, which means is that arc QR is 80 degrees. Now, using what we just known with that inscribed angles theorem. They want us to find the measurement of RS, and they want us to find the measurement of STR, and what do we notice? So here we say that we got RS, which is currently right here. Well, we have this angle here that points to angle RUS. So angle RUS is going to be equal to 31 degrees, which means that you just take 31 times it by 2, and that gets us your result of 62 degrees. Now, the other question they asked was, what is the measurement of angle STR? Well, it's still in respect to that same arc, and that arc we said was 62, so 62 divided by 2 is 31. So this is 31 degrees. So what do we notice about angle STR and angle RUS? Well, they're the same, which means that is there a theorem that allows us to make that assumption? Well, yes, there is. We can say that we have what is called an inscribed angles of a circle's theorem. So if you have two inscribed angles of a circle intercepting the same arc, which we did, then those angles are congruent. So if you notice that ADB, they share this same arc with ACB, and that means that those angles are the same. Okay. So using that theorem, it says, okay, well, angle E is 75 degrees. What is F? So if you look here, this 75 degrees is with respect to arc GH. So F has that same idea because, oh, look, it overlaps arc GH as well. So that means that angle F is going to be also 75 degrees. Another concept, one of the last concepts we're going to look at in this section is talking about inscribed polygons. Inscribed polygons is any polygon when all of its vertices lie on the circle. So like this particular polygon, every vertice touches the circle, all right, at some point. The circle that contains the vertices is a circumscribed circle. There are some theorem relationships to inscribed polygons. We're going to look at two of them. One of them is an inscribed right angles theorem. So if you have a triangle and one of the side measurements of that triangle happens to be the diameter, what that's telling you is that the point that is on the circle but is not part of the diameter, it's opposite of the diameter, that angle of that triangle makes it 90 degrees. The other theorem below is something that is a inscribed quadrilateral. And when you have a quadrilateral that's inscribed, they're telling you that the opposite angles are supplementary. So D and F are opposite angles in this case, and E and G are opposite angles in this case. So if you were to add up those two angles, their results are supplementary, which means they're going to add up to 180 degrees. So here, they want us to find the value of each variable. Well, since it's a triangle inside a circle and AB is a diameter, that means that using that theorem, that means that this angle right here is 90 degrees. So 2x is going to be equal to 90 divided by 2x is going to be 45. Looking at example B, we need to find Z and Y. Well, G and E are going to be supplementary. So y plus 120 is going to be equal to 180. I subtract 180, 120, which gets me 60. So y is going to be 60. And then if I go here and here, that means that z plus 80 is going to be equal to 180. That means z is going to be 180 minus 80, which is 100 degrees. And you can always check this by adding up all of those interior angles. And because it's quadrilateral, it should add up to 360 degrees, in which it does. And that is being able to look at inscribed angles and polygons. Hope this helps. Until next time.